Okay, ladies and gentlemen, we're going to be working on polynomials, which is 4.1. This is part 1. So poly meaning many. If you have chemistry, you'll hear about polypeptides. You'll hear about poly showing up in a lot of different things. So poly means many, and so polynomials is basically many numbers or many terms. There's 3 types that we normally address as their own kind of thing, and other than that, we don't generally distinguish too much. In the first case, we have monomial, which is one term, right? This is one term. And then here is a binomial. We have 2 terms. This is one term, and this is another. All right. Our trinomial has 3 terms. Our ax squared plus bx plus c, where a, b, and c are not equal to 0. All right, in this case, I'm going to go ahead and let's go 1x squared plus 2x minus 3x, or minus 3, not x. Okay, so in this case, and there's a reason I'm doing this. I'm going to talk about this in just a second. I want to kind of address that without it just being vague with letters and so on. Okay, so this is anything beyond trinomials. They normally just get dumped into the polynomial bucket. We're not going to distinguish between those. I've had people argue about whether monomial is a polynomial or not. I'm not going to argue about it. I'm going to say, for the purposes of this class, it is. All right, so if we have a polynomial, we're going to look for the greatest exponent, right? In this case, if I'm doing a quadratic, it's going to be a 2. So if I'm going to have my exponent 2, and there's nothing that's higher than that, then I say that whatever my coefficient is a to the n, or a sub n, so it's attached to the, let me actually do this. So I'm going to do a sub n, and then here is my, I'm going to circle my n. Okay, so n, and then 1, and that's n, and then x to the 0, this is my n here. So my a to the n is going to be 1. My a to the n minus 1, right? That's going to be the 2. And then my a, and this could also be my a to the 1, right? For the moment, I'm going to call this minus 1. So, and then I would have my a to the n sub n minus 2. Okay, this is also going to be my a sub naught, and here's my a sub 1, right? So for the purposes of this, it's pretty straightforward, but I wanted to make sure that it's real clear what we're talking about. So this is our n, I should say n minus 1, and this is our n minus 2. All right. So this is, I get the fact that this is very much an abstract concept, and this is, it takes a little bit of getting used to thinking about it in this like really abstract method, but hopefully I'm doing a decent job of helping you connect practical to the theoretical. All right, so here we have all of these numbers, all of these coefficients have to be a real number. And our exponents have to be whole numbers. Now, reminder about the whole numbers here. Our whole numbers start at 0 and go up like counting numbers. 1, 2, 3, and so on. All right? So this is our case where it becomes really important to know that you are what your terms are. In this case, the whole numbers. You can't have fractions. You cannot have negatives. All right. So when you have sorted out your terms, you've got your first non-zero coefficient a sub n. It's called the leading coefficient. That's going to become important in a moment. The term an, or a sub n x to the n, is the leading term, right? The term has the x attached to it. The coefficient is just the number in front. That leading exponent, that n, indicates the degree of the polynomial. And every polynomial function of degree n, where n is greater than or equal to 1, has at least one zero and at most n zeros. We've actually kind of talked about this. I said you could have, if you have real numbers, you have to, if it's going to be touches the real numbers, then it has to either be a 1 or a 2 for the quadratic. If it doesn't touch the real numbers, then you'd have a complex solution, which was no real solutions. But for quadratics, again, already we know that the most solutions you can have is 2 because our largest exponent is 2. Okay? Now, when I say the leading coefficient, the first coefficient, I want to point out that if I have something like this, all right, if I have something like this, where I have here the largest is on this side is x squared, but on this side I have an x cubed, I need to move things around so that this is set equal to 0. All right, so I'm going to have 7x to the third, and that's going to be a negative now. I'm going to have my plus 3x squared, and then that's going to become a negative x, and then this is a positive 1. And so now my leading information, my leading term is this. And so my a sub n on this equals the negative 7. All right. All right, so polynomial functions. We're going to show an example. We're going to talk about what the degree is, the leading term, and the leading coefficient. And we're going to talk about the one and only exception. I'm going to make this quick so that hopefully we can, we'll pick this up here in a moment, but I don't want to burn this up too quick. So we're going to have a constant. If you have f of x equals 3, remember that's a horizontal line, it's just flat. Our x to the 0 power is a 1. Right? That's true for every number except 0. 0 to the 0, we don't know what it is, and I'm not going to argue about it. So degree 0, right? Because here's the 0. So in this case, if you wanted to really be specific, you could say 3 multiplying the x to the naught, or x to the 0. All right? But normally we don't include that, so most times we would just say 3, and then our leading coefficient is 3. And this is the one and only case where those are going to be the same. Your leading term and your leading coefficient are the same when you have a constant. And again, that one exception is going to be 0. All right, so linear functions, we know about those. That's going to give us a slope and then our intercept. And if you stop and think about our slope, that's got that x has an exponent of 1. So our degree is 1. Our leading term in this case is going to be 2/3 x. And the leading coefficient is 2/3. Right? That's different from the leading coefficient in the leading term, right? You've got that x or not. For my quadratic, my highest term is 2, so my degree is 2. In this case, my leading term is 4x squared. My leading coefficient is a 4. Cubic, my highest exponent is a 3, so my degree is 3. I have 1x cubed, or I have x cubed, right? I could have just left the 1 off. But you need to be sure, this is where people trip up a lot, is you have like an x cubed or a negative x to the 4th, and people will just move it over to the leading coefficient without pausing to think that this is really a 1 and this is really a negative 1. So your leading coefficients are going to be 1 and negative 1 respectively. Now here's our one exception. All right, our one exception is that constant functions where f of x equals 0 has no degree. And that's because 0 can equal 0 to the first can equal 0 to the 72nd. And then I have 0 to the 7,426. All of those are going to be the same. It's always going to be 0. So we say that it has no degree because clearly it's not 72 or 7,426 or even 1. Okay, it has no degree. And that is the one exception. And I'm going to stop here and we'll resume on the next video.